I'm Ennemcien. We have to see a few points about reflection by a plane mirror. First point is a plane mirror always forms virtual image. That is, image will be formed behind the mirror. What is the meaning of virtual image? By virtual image, you mean that you cannot project the image on a screen. But you can see the image because the crystalline lens of your eyes will focus light, the reflected light, onto the retina of the eye, and you can see it, but you cannot project the image on a screen. That is the meaning of virtual image. Another point is distance of the image from the mirror will be equal to distance of the object from the mirror. Another point, the image is always erect. If the object, the head of the object will be the head of the image at the top upper end, and the tail will be at the lower end. That is erect image means. Next point is size is the same. Size of the image and size of the object will be the same. Another very important point is suppose you move this object with the velocity v away from the mirror, then the image will also move with the same velocity in the opposite direction like this. If v is the velocity of the object relative to the mirror, then velocity of the image relative to the mirror will be v itself in magnitude, but direction is opposite. But if the velocity of the object is v, then velocity of the image relative to the object, what is that? We must find out. So here velocity object is, original velocity of the object is v in this direction. Now if you have to find the relative velocity of the image, you must bring the frame of reference to virtual rest or in imagination. For that, here the frame of reference is the object. So object must be brought to virtual rest. What must be done? You add a velocity v in this direction. So that total velocity of the object will become v minus v equals 0. That is, it is virtually at rest. Same must be done on the image also. So here original velocity of the image is v in this direction. You should add this velocity here also in the same direction. So now the total velocity of the image is v plus v or 2v. So this is the relative velocity of the image with respect to the object. So velocity of the image relative to the mirror is same as that of the object, but direction is opposite. Velocity of the image relative to the object will be double the velocity of the object, but in the opposite direction. If the object is moving towards the mirror, then the image will also move towards the mirror. The rest of the calculations same. Next point is, if this is a piece of plane mirror and this is an incident ray of light, this is reflected in this along this path. If you turn the mirror through an angle theta, then the reflected light will change its direction. This is the new reflected ray, and this angle will be 2 theta. That is, angle turned by the reflected light will be twice the angle turned by the mirror, provided the incident ray is the same. This is very important point. Now, so angle of rotation of the mirror is theta, then angle of rotation of the image reflected light is 2 theta. So what is the angular velocity of the mirror? Omega equals theta by t. Then angular velocity of the image will be 2 theta by t, or that is 2 omega. So angular velocity of the reflected light will be twice the angular velocity of the mirror. Another point. These are two plane mirrors M1 and M2 arranged with an angle alpha degree between them, and an object is placed in between the mirrors. Then the total number of images formed by the pair of mirrors is given by this formula: n equals 360 by alpha minus 1. Here alpha must be in degree, not in radian, in degree. So suppose M1 and M2 are parallel. These two mirrors are parallel and image is placed in between them. Parallel mirrors means alpha equals 0. So number of images is 360 by 0 minus 1. 360 by 0 is infinity. So n is infinity. Infinite number of images will be formed by a set of parallel mirrors. If the mirrors are mutually perpendicular, then alpha is 90 degree, then n equals 360 by 90 minus 1, or that is 3. Sometimes the 360 by alpha may not be a whole number. For example, suppose 360 by alpha is 5 point something. Then you take 360 by alpha as the greatest whole number. If alpha is 360 by alpha is say 5.6, then you take 360 by alpha as the greatest integer 6. Then number of images formed is 6 minus 1, that is 5. Remember this point. Another point. These are two plane mirrors, M1 and M2, mutually perpendicular. This is an incident ray of light, incident at an angle of incidence theta. This is reflected from here. Angle of reflection below. So this is reflected and strikes the second mirror at an angle 90 minus theta. You can calculate this easily because this angle is 90 minus theta. So this will also be 90 minus theta. Then this is reflected at the angle, same angle, 90 minus theta. Just you add all these angles, theta plus 90 minus theta plus 90 minus theta. You will get it as 180 degree. That is the total deviation produced by the pair of perpendicular mirrors. That is, incident light is like this, but reflected light is just opposite. That means angle between these two rays is 180 degree. That is, angular deviation is always 180 degree irrespective of the angle of incidence. Whatever be the value of theta, these two rays will be parallel and direction will be opposite. Or deflection is, angle deviation is always 180 degree, whatever be the angle of incidence. This is very important point. Another point. Suppose this be a transparent material, say glass, water, etc. Then this is ray 1. This is ray 1 incident at an angle of incidence I1. This is reflected this way. This is reflected light incident at an angle theta 2. higher angle, a greater angle. Then this is reflected along this path. It can be shown that intensity of this second beam will be greater than that of the first. As the angle of incidence increases, when we consider a transparent material, light incident on a transparent material, intensity of reflected light becomes greater as the angle of incidence becomes greater. You can see, suppose you throw a piece of stone, light stone, onto a water surface. If the angle is nearly equal to 90 degree, that is 90 degree with it perpendicular to the water surface. That is, if you throw the stone through a line nearer to the water surface, it will be reflected. If you throw it at an angle nearly equal to the angle of the normal or nearly equal to perpendicular to the surface of water, the stone will sink, go into the water. So as the angle of incidence approaches grazing, intensity of reflected light will be higher. This is very important point. Another point, this is a plane mirror. This is an incident light. It is reflected along the path 1. This is received on a screen. So I1 is a light spot produced by this beam. The mirror is turned through an angle theta. So that reflected light will turn through 2 theta and it will come to a spot position I2. Then the shift in the position of the light spots I1, I2 equals delta is given by D. D is the distance between the mirror and the screen into 2 theta. Here theta must be in radian. This is same as S equals R theta. I have discussed all these things in one of my earlier postings. So angle of deviation or shift in the position on the screen where the reflected light hits D into 2 theta. This is very important point. One more point. If a person of height h stands in front of a plane mirror, and what must be the height of the length of the image or height of the vertical image fixed on a wall, so that the person can get his full view, full length in the mirror. What must be the length of the mirror? The minimum length of the mirror must be h by 2. If a person of height h is to see his full image in a vertical plane mirror, the minimum length of the mirror must be half of his height, h by 2, whatever be the position of the person. Irrespective of the distance between the person and the mirror, the minimum height of the or length of the mirror should be h by 2. Now we will see spherical mirrors, refraction, etc. in several postings. Thank you.